Okay, hi guys, welcome to a quick start. And today I will be doing justice to some of the WAEC questions that we have done in the past year. So, and I believe we're going to do justice together. So here we have the question is saying the time T taken to buy a fuel at a filling station varies directly as the number of vehicle V in a queue. So the time T, the time T varies directly at the number of vehicles, which is V, and at the same time in a queue, and it also varies inversely as the number of pumps available in that station. So that means the same VT we have, it also varies inversely as the pump. You understand? Where T is time, V is vehicles, and our P is the pump. So if we combine these two variations, we have this vehicle and pump. So just to make things easier, we can introduce our constant T equals to the constant V, vehicles and pump. That is how most questions largely look like. So now we continue. It says in a station with 5 pumps. So we have 5 pumps. That is, in this case, our P equals to 5. Then we also have it took 10 minutes to fill 20 vehicles. So we have the time is 10 minutes and the number of vehicles is 20. So we can introduce this value to get our constant K, which is 10 is equals to K multiplied by 20 all over 5. So when we cross multiply, we have 50 is equals to K, then 20. Then we divide both sides by 20 by 20. So our K will be 5 over 2, or we'll say 2.5. So we can bring it back into the equation. But I'm sure the first question would definitely be which generates the equation of the relation. So we'll put it in here, B all over P. This will likely be the first question in most Y equation. So if we look at the relationship between T, P, and B, that's the first question. Question 2 says, take the time it takes to fuel 50 vehicles at a station with 2 pumps. So in this case, we have question 2, we have our V to be 50, and the station is having just 2 pumps. As still in our question, we are just 2 pumps, the time it will take. So we don't know our T now. We can say 5 times V, which is 50, all over the pump, which is 2. So we can see our time is 250 all over 4. So when we divide this by 4, 4 in 25 we have 6, and we have 4 in 10 to be 2. So it remains 2, that's 2 over 4. So it takes roughly 62.5 minutes. And the question that we have there once again is the number of pumps required to fuel 40 vehicles in 20 minutes. Number of pumps required to fuel 40 vehicles and time is 15 minutes. So we'll bring in our relation again, which is 5V all over 2P. So our time is 15, and we don't know the number of vehicles, but we know that, okay, our vehicle is 40 rather. Our vehicle is 40, so we'll say multiply by 40. Then we don't know the number of pumps that we're going to need. So if we cross multiply this, we have 30P is equals to 200. Divide both sides by 200, by 30 rather. So the number of pumps we might likely need will be 6, roughly 6. That's our 6 to number 2 over 3 pumps. Thank you, and God bless you.